Have you ever watched the stars during the night? They sure are beautiful to look at. As tiny as they might look to you from wherever you might look at them, those stars are actually burning that are comprised of mostly hydrogen and helium. These gases are held by gravity to form a dense pressure right at their core to produce heat and energy. That is how they emit light. Just like the stars, our sun is a star too. It does what stars do. It generates energy by fusing hydrogen and helium in its core, creating energy in the process. This fusion of these gases is called a nuclear fusion, which gives out nuclear fuel. The amount of pressure and gravitational force this produces is what makes the sun emit heat and light together. It's no surprise that our sun can generate a lot of energy. A lot of it has to do with its mass. For stars to produce heat and light, it sure depends on how big they are. The volume or mass is equally proportionate to how much the star can actually give off its energy. The larger the star's volume or mass, the more energy and heat it can generate, as it will have more hydrogen to burn. Are you curious to know about the size of our sun? Well, for starters, our sun is supermassive and enormous. The radius of the sun measures approximately 696,340 kilometers. If you put it in a diagrammatical way, it is roughly 1 million times the size of Earth. Astronomers have found that our sun comprises 75% of hydrogen and 25% of helium. With so much hydrogen, it's no wonder our sun can generate so much energy. With the amount of hydrogen our sun has, you can imagine how much heat it produces. It's even more than what we face here on Earth, considering Earth is 151.94 million kilometers away from the sun. The sun's surface temperature reaches 5,500 degrees Celsius, while its core temperature is around 15 million degrees Celsius. Now, there's no doubt that without the sun, the solar system wouldn't have been formed and life on Earth would not have come into existence. So, it leads us to a question. How did the sun come into existence in the first place? Though we don't know precisely how our sun was formed, many scientists have discovered that our sun and the rest of the solar system were formed from a massive revolving cloud of gas and dust called the solar nebula. As the nebula started spinning faster, the gravitational force produced by this motion caused it to flatten into a disk and to collapse. The particles that were suspended were dragged to the center by the gravitational force. Thus, this is how it all began. Do you think the sun will keep burning forever? Well, our sun today has enough hydrogen to burn for the next 10 to 11 billion years. But what will happen if the hydrogen runs out? Well, like all stars, our sun too will die. The reason for this is that it either runs out of nuclear fuel due to its mass, large stars quickly deplete their hydrogen fuel, or it is hot enough to fuse heavier elements like helium and carbon. When they die, they either turn black and vanish, like how the red dwarf stars do, or they explode like a supernova. But don't worry, our sun won't explode like a supernova because a star needs about 10 times the mass of our sun to explode as a supernova. When will our sun die? Well, according to scientists and astronomers, a sun with the same mass as our sun can surely live for another 10 to 11 billion years on average. Our sun is 4.6 billion years old today. This means that it's already halfway through its stable life. So does it mean that our sun is drying out? Like we've previously mentioned, our sun is a star, and like all stars, there is a start and an end. The main reason for our sun's end will probably be that it has run out of hydrogen. And considering the size of the sun, the amount of hydrogen it burns every second is massive. But when will this happen? Well, let's fast forward to 5 billion years. By this time, the outer core's hydrogen will have depleted, leaving an abundance of helium. Excess helium in the outer layers will fuse into heavier elements such as oxygen and carbon. These reactions don't produce much energy, and even if they do, they won't be able to output nearly as much as a conventional sun. While this reaction takes place, our yellow star would have begun to swell. Why would it swell, you must be thinking? Well, this is due to the heavier gases generated, such as helium, oxygen, and carbon, taking up more space on the sun's surface. The swelling will be so massive that the sun will engulf its planets. Mercury, Venus, and Earth would all be enveloped by the sun. It could potentially expand to swallow even more planets. It will grow so large that it will become red, or red giant as astronomers refer to it. Would this be the end of life on Earth? Well, one thing is for sure, when all this happens, humans won't be around. Before the sun even reaches this stage, human life would have already ceased to exist. In fact, scientists predict that humanity has only 1 billion years left. Why do you think so? Is it because the sun will be a little brighter? Well, yes. You ought to know that every billion years the sun's rays get brighter by 10%. Now you're thinking that 10% doesn't sound like much, but that increase in brightness will indefinitely end life on Earth. And let us not forget how hot the Earth's surface would become. Humans will most likely become extinct, and our oceans will likely vanish. Water will not be able to form on the Earth's surface because it will be too hot. The sun would have grown too big and bright by the 6th or 7th billionth year, but it would no longer be able to give off heat. With its gravitational force reduced, the sun would also be losing more mass into space. This could cause other planets orbiting the sun to stray. The sun's outer layers will gradually erode as more gas and dust are ejected into space by the sun. It will continue to peel away layers until the core of the sun is revealed. It will be the 9th billion year by this time, and the sun will have run out of hydrogen to burn. With a limited supply of hydrogen and more helium, the mass will begin to shrink. The once red giant will now regress to a white dwarf. However, white dwarf stars are in fact still extremely hot, though not nearly as hot as the sun. And as the hydrogen begins to run out, the sun will fade out and become a black dwarf. By this time, all the hydrogen is burned out of the sun's core, and the sun will die. But don't be alarmed, all of this will occur in the next 7 billion to 8 billion years. So if you enjoyed this video, please like it and share it with your friends because, well, let's face it, we all need to know something about our sun. And if you're a space geek who enjoys watching videos like this, please subscribe and press that bell icon for more updates. Thank you for watching, and I'll see you next time.